So for those unfamiliar with Harmonic, we are a real-time database of basically the startup ecosystem. We track 37 million companies, 200 million people, 220,000 investors, and more getting added each week. Most of the VCs that you have heard of rely on Harmonic for their sourcing. I think 9 out of the top 10 current VCs use Harmonic. So Scout is basically the layer that sits on top of this whole ecosystem. It's a natural language interface that runs on deep agents and connects to the data. So I can handle simple queries like who is the CEO of LangChain, as well as really complicated stuff like map out the landscape of this industry, create a visualization of how the market map looks, and rank the team on a scale from 1 to 10 based on this rubric. What it'll do in the background is basically run through a tool loop, execute it, and then render the response to the user. And this is both the combination of a chat interface that you would see with something like Claude Code or ChatGPT, but we also have some custom-built UX, which I'll get into in a bit, that makes it integrate really nicely with the ecosystem. So you can click on the companies here and add them to lists, and pull up sidebars and whatnot. So it's interactive, but also kind of keeps to the conversational flow that the agent wants to. And just to kind of demonstrate how successful Scout has been since we switched to deep agents, metrics are fun. We had 4 times the retention from week 1 to week 4 since we switched over to deep agents. But we've also gotten some really great qualitative feedback. And I always love this because it's not just like, yeah, it's pretty good. We enjoyed using it. We'll probably use it again. But people are saying literally, like, I talked to some colleagues from other firms. I think everyone's secret weapon is becoming Scout. One person said it's like my heaven. So that's always good to hear. So Scout 1.0, this was our initial version. I think it was cutting edge like a year and a half ago, and it very quickly became not cutting edge. And the concept here was basically, how do we take a natural language query, someone's looking up, show me all the fintech SaaS companies in New York that have raised money in the last 2 months. We had this query parsing graph that would take it, extract out the the semantic portion, fintech SaaS, run that against embeddings. It would take the location, it would take the funding portion, and kind of route that to our own custom search language. And each one of these nodes in LangGraph, we would, had their own models, had their own evals. We would tweak them, like crazy to make sure that they were passing the evals, and required a ton of maintenance. Fast forward to, the models become a little bit better, the harnesses start to come out, and we switched over to deep agents. So the graph is a lot simpler here. Essentially, we have just a tool call loop in the middle. You have the model, you have tools, and then you have middleware that Robert kind of alluded to, that runs before the model, after the model, and before the agent and after the agent, which is the entire tool calling loop. So we basically switched entirely over to this version, which is simply model and tools, and then we created a bunch of tools that connect into our ecosystem. So everything from searching entities, searching the web using Tavily, and then other stuff, enriching by ID, enriching by URL, as well as kind of interfacing with the user CRM. They can add it to lists, manipulate lists, move things around. So we found that using frontier models and the harness, giving it a bunch of tools, even 50 tools, it's able to kind of choose the right tool, execute really complicated, long composite tasks really well. So we talked about the agent is model plus harness. Again, in this case, we are using a frontier model, and we're using deep agents as the harness. And a little bit why we chose deep agents here. We had these really, again, we had 50 tools, a lot of different interactions. Some of the threads can get very long. If you're conducting a company search where there's 1,000 results coming back, each one of those companies might have nested team members and funding information and all this other stuff. The actual response that comes back could be thousands or tens of thousands of lines long, depending on what the model chooses to pull in. And if you're just passing that into a model through a messages list, that can get very crowded very quickly. So deep agents, I think one of the core benefits of it is it handles, it basically manages context. So if the messages list gets long, it'll run compaction, so you can keep going pretty much infinitely. And tool call eviction, so that company search call that returned thousands of lines, it would actually pull that into the file system and return a pointer to how to basically pull in chunks of that file so that the model can continue without getting polluted by the entire response. And I'll get into that a bit later. As well as skills and custom middleware lets us pull in prompt information at runtime rather than having it all included in every single call. File system abstractions, which lets us, arbitrarily read and write different artifacts into the agent. And most importantly, we were already on Linksmith deployment with our previous agent, the spaghetti graph. So it was so simple for us to basically take this new framework, plug it into the existing graph. The users still saw the same chat interface, and we were able to kind of incrementally, A/B test and move people over. So if the agent is model and harness, I kind of want to talk about how we take the agent, which contains a lot of technical primitives, and actually build it into a product that people can use. So in this model, if the agent is model plus harness, the product means that you're adding some sort of UX on top of it so that the users can interact with it in a nice way. In this case, Scout, again, frontier model, deep agents as a harness, and then a web interface that we built to kind of fit into that, to plug into that harness. And the central tension that we found is that these agents love things that feel like code. Like the models are trained on coding tasks, tool calling, structured JSON. They love to structure things as XML or JSON or whatever in the response. And then also the harness, we have things like the file system primitives, and it's going to write things to Markdown, and it might output, hey, I wrote this file to this path. And the user doesn't want to see that unless they're actually an engineer. Most of our users are non-technical. So we had to basically fight this tension of how do we leverage the full benefit of this harness that is extremely capable with a correct model, and then build it into a product that is generally useful to people without compromising some of that power. So again, the tension between making sure the model has agency to reason and act freely, with building a UX that's kind of nicely interactive, has rich elements that are rendered in a predictable and deterministic way. So the way I think a bit about the context that the harness manages, it basically has a contract with the model. So the model is always just getting a list of messages, assistant message, human messages, tool messages. And that's essentially all that's happening. Every time you call a model, you're passing in a list of messages. It's streaming back whatever comes next. So the harness's job is to basically pull stuff out of that messages list to make room and make sure that you're not, hitting the context window or hitting context rot. So in this case, everything that's in the messages list is always visible to the model. Everything that's offloaded by the harness kind of exists in like the purview of the agent, but might not necessarily be directly available to the model at every call. But the contract is that anything that the harness kind of pulls out of the messages list, it has to make available to the model through tools. So if it's pulling out a file, it returns a pointer to the file saying you can access it at this path, and it'll give tools to kind of read chunks in at a time. So the concept of progressive disclosure, you have kind of an initial like lightweight one-liner of what exists and some tools, and then the model can kind of choose to build up context in chunks as needed. But the important thing here with regard to UX is that anything that sits outside of those two layers, the message list and the harness, is basically invisible to the model. So if you're building a UX and you have something that's like nicely rendered like side by side with the conversation, but it doesn't exist either in the message list or offloaded by the harness with a way to discover it, it'll be essentially invisible to the agent. So to make this a little bit more concrete, with Scout, one of the most interesting use cases that kind of emerged as we built this up and monitored outcomes was visualizations. People started asking, can you make me a chart of this or a market map graphic of this industry? And we didn't really have any way to display it, but the model would try to kind of print out SVG code or like HTML and CSS and stuff, and we're like, that's kind of cool. So we basically try to figure out, okay, these actually look pretty good out of the box. How do we turn that into an actual like product surface? So I could kind of talk about the wrong way and the right way to approach this based on that harness contract. The improper way would be to basically expose a tool that says, render this data. So you'd pass in some arguments, and then it would return something like success true or some sort of no up. The problem with this is it knows, and it would call that tool, and then the front end would like intercept that call and render something based on that data. The problem with this is that the agent has no idea what actually happens because it's kind of just firing something into the void, getting back some success message. But if the user says, what is why is that company on the left-hand side? It doesn't have any context on what the front end is doing because it's completely outside of the purview of the harness. And again, going back to this diagram, it's on the bottom. There's no way for the model to develop progressive disclosure to access that information. The easier way to do this is to basically have it live entirely in the messages list. So with things like visualizations, generally they're small enough that it's not a huge deal to just have it directly in the assisted message. So you could do something, basically prompt the agent to use some sort of delimiter, in this case, an XML tag, HTML visualization that wraps whatever HTML it's going to use to print out the visualization. The front end can intercept that as part of the output. It can render the graphic in real time. But most importantly, the model has full visibility into what's happening. If you say, why is that company on the left? It knows why, because it did it. If you ask it, can you regenerate this and move these three things to the right-hand side and change the background color? It has full agency to kind of modify it, and it's fully living inside the messages list. So this is easy enough when it's something small like a visualization, because we could just make sure it's always visible to the model by being in the messages list. But one of the biggest use cases for Harmonic is searching companies. And someone might want to do that search from earlier, find fintech companies in New York, and there's probably, I don't know, tens of thousands of them. So we have to basically expose a way to conduct that search in the front end and make sure that the agent has awareness of what the results are. But it's probably too big to have 10,000 lines in the messages list just kind of thrown into a human message or a tool message. So again, the kind of naive way to do this would be to fire and forget. The model would trigger a search. And by the way, when I say naive, like this is what we did at the beginning, and it caused a bunch of issues. The model would trigger a search. It would call some sort of search service. The front end would intercept that call and start to render that side by side. But there would be no information making it back to the model. So a user would follow up and be like, great, there's 5 results at the top. I don't know why they're showing up here. Or like, can you tell me more about the CEO of the second company? The model doesn't have any context and doesn't have any way to even like build up context to know what exists there. So the user's seeing this great thing, but then the agent loses ability to build up that context. A better approach here would be to create a tool that returns some sort of identifier, and then tools to explore that artifact a bit. So the model would call something like start company search. It would execute the search and return back like an ID of the search, some sort of status, the count of results. And then the front end would intercept that, start to render the results as they come in. But then the model has the search ID, and it has tools to inspect the artifact. So it could say something like, get the search status for this search ID. Or it could say, fetch the first 10 results, or the second, second batch of results from this search. And it's able to build up that context. So if the user then asks, why are these 5 companies at the top? It's able to be like, let me take a look. It's not directly in the messages list, but it could say, let me take a look. It'll fire off a tool call for fetch the first 10 results. And then it'll be able to answer the user. So this is the better version. The best version is a deep agent's native version, which is basically using the file system as a shared storage space for basically the agent, the front end, and any other kind of deterministic processes that you want to run. So the main agent, as part of the deep agents framework, has file system tools. So it has the ability to kind of navigate this scoped file system that gets created. It can do read files, ls, cd, grep. And then we would be able to basically fire off a second search agent that would mount to that same file system that the main agent's running on. It would be able to kind of fire off a search that might run for a while. It might run some kind of custom evaluation and rank them and sort them and whatever, but it's writing to the same file system. So while that's happening, the main agent has the ability to kind of arbitrarily inspect the output and the status. The front end can still kind of connect to that same file system. We expose an API to render the results directly from there. So then everything is kind of in harmony. The front end can view the results as they come in, like up to tens of thousands of results, ranked, sorted with annotations. The search agent is kind of continuously pumping data in by just writing it to this file system. And then the user can still ask something like, why are these 5 companies at the top? Or, draft outreach emails for the top 5 companies. And the main agent would be able to be like, okay, let me read this file. I know the path of where this is being stored. Let me read the first 10 lines. Let me read the next 10 lines. And it's able to kind of piece it together. So final kind of just tip of what we've learned as a kind of a heuristic for if you're going in the right direction or not. If you find yourself kind of fighting against the model, if you find yourself saying like, trust that this is being rendered, like after you call this tool, the user will see this, like believe me, like don't respond, don't include this in your response. Like it's kind of a sniff test that something might be invisible to the model, or it might be something that could be better solved by kind of designing better first principles, like flow of context between the harness and the model. So to recap, agent is a model and harness. The product adds UX on top of it. The UX has to play by the rules of how the harness shares context with the model. And the model needs to have progressive visibility into any artifacts shown to the user, or else it's invisible to the model. All right, thank you.